This is Israel coming at you from Einstein High School. I'm going to do something a little different for our third video. We're still in Unit 1, Topic 1. But because these next few problems are so similar, we're actually going to do them together. In fact, the directions for items 3 through 5 are going to be the same for each question. Let's read them. For items 3 through 5, solve each equation, then select the appropriate choice from the 3 choices below the problem, and fill in that blank space for that choice only. Now you notice here I've given a lot of space because we're going to come back up, but let's go ahead and take a look at our answer choices. All right, here's number 3, and if you look at 3, 4, and 5, you'll notice the answer choices are the same for each problem. Our answer choices are going to be, there's one solution, and it is. The equation is always true because, where we'll provide an explanation of why it's always true. And finally, C, the equation is never true because, and again, we'll provide an explanation for why that equation will never be true. So let's go up. I have my empty space up here, and I'm actually going to write a little note to remind us about one solution, always true, and never true. Okay, let's start with one solution. What this might look like, you go to solve your equation, and there's exactly one solution to that equation. For example, I solve my equation and I get the solution x equals 2. That's what it's going to look like if we end up with just one solution. We're able to solve, we take it through the finish, and we get one number, one value of x, like x equals 2. The next choice is that the equation will always be true. What that might look like, I'm going to solve my equation and I reach a point of the equation where I notice that I have identical expressions on either side of my equation. When you reach that point, I want a light bulb to go up in your head, and what we're going to notice is that we know this equation is always true. Well, why does that work? Let's take a value for x, like 2. I'm going to substitute 2 into both sides of my equation. Okay? I'm going to simplify each side of the equation. So I have 3 times 2 plus 4, which is going to give me a value of 10 on each sides of my equation. And notice we get the exact same thing on both sides, and I hope that we can agree that 10 does in fact equal 10. Now for any x value we plugged in, we know that the 2 sides of the equation are going to be equal. The final answer choice is never true. What this might look like, I reach a point in my solving where I have the exact same x term on each side of my equation. Different numbers, different constant terms. So in this case, I have the same x term, 2x on each side of my equation, but different constant terms, positive 5 and positive 3. So what happens if I try to solve this? I know that I need to bring my variables to one side, my numbers to the other. So I'm going to start by taking 2x to the left. It's a positive 2x, so I'm going to subtract that value using the subtraction property of equality to each side of my equation. Oops, my screen jumped there. Give me a second. And hopefully what we'll see is we end up with 0 for each x term, and I'm left with 5 equals 3. Well, we know that 5 does not, in fact, equal 3. Therefore, we would say that this equation is never true. So again, we're looking for a few different answer choices, a single solution, as in x equals 2, identical expressions on either side of our equation, or identical x terms that will leave us with an equation that is never true. 5 does not equal 3. Okay, now we're ready to go ahead and try problems 3, 4, and 5. So starting with number 3. We're going to solve our equation, and we're going to decide if this equation has one solution, is always true, or is never true. Give myself some room here. Okay, let's look at number 3. We have the equation 4x plus 2x plus 18 equals 5x plus x plus 18. See a lot of x values here, and so what that tells me is I'm going to combine like terms on either side of the equation. I'm going to combine any like terms that I have. So let's do that with our x values on each side of the equation. On the left side of the equation, I have 4x plus 2x. Those are like terms. And on the right side of the equation, I have 5x plus x, and those are also like terms. We only combine like terms on the same side of the equation. Okay, so on the left side, we have 4x plus 2x is equal to 6x. And I'm going to bring down our positive 18. On the right side of the equation, we have 5x plus x. Well, this is also equal to 6x plus 18. I'm going to pause, take a moment, look at our answer choices. Have we made a decision? Is there one solution? The equation is always true. The equation is never true. Hopefully you noticed that we have identical expressions on each side of the equation. Therefore, we know that this equation is always true. I'm going to circle B, and our explanation is going to be that each side is identical. All right, let's move on to number 4. Number 4, we have 5 times x minus 2 equals 6x plus 20. Hopefully we notice that the first thing we're going to need to do is distribute our 5 to each term inside the parentheses. So we're going to use the distributive property and multiply 5 times x and 5 times positive 2. Notice I kept the subtraction sign in the middle. And we're going to keep the right side as 6x plus 20. All right, let's simplify. We end up with 5x minus 10 equals 6x plus 20. Give myself a little bit more room here. All right. From here, we need to get our variables to one side, our constant terms to the other. Our goal, again, is to solve for x. So what I'm going to do is take that 5x and move it to the other side. So let's work with our x terms first. We have 6x and 5x. In order to move a term to the opposite side, we need to do the opposite sign. So we have a positive 5x. We're going to use the subtraction property of equality to subtract 5x from both sides of our equation. On the left side, we're left with negative 10. On the right side, we're left with a single x. 6x minus 5x is 1x, and plus 20. I'm running out of room here, so follow me over to this corner here. I'm going to rewrite that. We have negative 10 is equal to x plus 20. And we're really close to having x by itself. We have a plus 20 that we need to get rid of. Since we have positive 20, we're going to do the opposite sign. So I'm going to use the subtraction property of equality here again and subtract 20 from both sides. On the left, I have like terms. I can combine them, negative 10 and negative 20 for a total of negative 30. And on the right side, we've now gotten rid of that plus 20. We're left with 0 and a single x. All right, we had to take that all the way to its finish. So I hope we now know that our correct response is going to be A. There's one solution, and it is negative 30. Okay, moving on to problem 5. All right. We have the equation 9x minus 3 equals 9x plus 15. Let me read that again, excuse me. 9 times x minus 3 is equal to 9x plus 15. All right, hopefully just like in number 4, we notice that we're going to need to distribute that positive 9 to both terms inside of the parentheses. So we're going to use the distributive property. 9 times x minus 9 times 3 is equal to 9x plus 15. All right, I'm going to simplify that left side. We end up with 9x minus 27, 9 times 3, is equal to 9x plus 15. All right, we've reached a point in this equation where I notice that we have the same x term on both sides of our equation. So I see that 9x twice. Let's go back, think about those 3 choices that we have, and hopefully we remember that when we end up with the same x terms on each side, different numbers, in this case negative 27 and positive 15, we now know that this equation will never be true. I'm going to go ahead and circle C. Why is this the case? Well, let's take it a step further. I'm going to come over here. We know we're going to cancel out those 9x's, and we know and can agree that negative 27 will not equal positive 15. And that's our explanation. I'm going to stop here. That was questions 3 through 5, Unit 1, Topic 1. Thanks for listening.